It's June 25th, 2014. This is Arizona Mining Review. I'm your host, Lee Allison, here at the Arizona Geological Survey in Tucson. Normally, we start off our shows with Niall Nemeth Skyping in from our office in Phoenix to give us an update on what's the latest news in the mining industry in Arizona. But Niall and his team are packing to move to new offices in Phoenix, and so he's not going to be available with us today, but I'm sure next month he'll have a lot of good stories to report. Well, right after our episode aired last month, I was in Washington, D.C. at the White House Energy Data Palooza. And it was quite an event. About 500 folks showed up to take a look at some of the new data initiatives, big data, digital data going on that relate to energy development across the country. And one of our projects, the National Geothermal Data System, was officially unveiled publicly by Secretary of Energy Ernest Moniz as part of the event.
And in fact, today, let me just summarize a few of the things that DOE has underway in using big data, maybe not so big data, in supporting private sector innovation to advance clean energy. Also announcing the National Geothermal Data System, accessible to the public. Its geoscience raw data can pinpoint geothermal sweet spots for researchers and developers, and hopefully will help drive our engineered geothermal opportunities to full potential.
There were only two other projects that he talked about in his remarks, so we were really impressed at the way the White House and the Secretary of Energy have focused on this big project. Now, it's not just energy, but it's a variety of geologic maps, databases, reports that we've brought together from over 60 different data providers across the country. And they're linked together in a federated online data system. And we're finding that the oil industry, the mining industry, geotechnical industry, many users are already diving into this incredible data system. We've got over 10 million different data points and records from across the country being fed in live by the people who collected the data, own it, maintain it, and they're sharing it in this distributed system. There's over 3 million oil and gas wells, perhaps 1 million oil or water wells right now, and 47,000 reports and geologic maps covering all kinds of topics and types of data. So we're looking forward in the future to working with our own data set here in Arizona that we've been developing, where we've been digitizing hundreds of thousands of pages of mining records, of maps, historical photos, and we've talked about that in previous episodes. That whole data system is being linked in with this National Geothermal Data System, and it's all built on the same platform, the U.S. Geoscience Information Network. And it's a way that we're bringing data, databases, maps, documents together from resources all over the country and increasingly worldwide. And so as the system gets more use and more people discover it, we think we're going to find new opportunities and new users and new providers of data. So stay tuned with us, because in the coming months and years, I think we're looking at creating something like a national mineral data system, a mining industry network or a mining information network. Things that are being built in Europe and we're seeing built in other regions across the world. We think we're right on the verge of being able to build that same capabilities across the U.S. and really take advantage of it, in particular here in Arizona. Well, joining us now are two researchers from the University of Arizona, the Superfund Research Program. Dr. Karletta Chief is an assistant professor in the Department of Soil, Water, and Environmental Sciences at the University of Arizona, and Denise Moreno Ramírez is the Community Engagement Core Coordinator. So welcome both of you. Thanks for coming.
Thanks for having us.
Okay. Tell me a little bit about the Superfund Research Program, and then I want to get into this new efforts you have on mining modules. But what is the Superfund Research Program?
The Superfund Research Program is a program that's housed in the University of Arizona and is consisting of various departments and schools across the University of Arizona that are focusing on hazardous waste and mining impacts across Arizona in terms of a variety of research emphasis that could be very scientific based all the way to engaging the community and providing information to the community stakeholders.
Okay. And I know, Denise, I first met when you gave a presentation to the Mining Alliance luncheon here recently in Tucson, and I think one thing that caught everyone's attention was the sense that this program isn't aimed at making the mining companies guilty of creating Superfund sites or something, but working with them to try to resolve some of the problems. So, Kimmy, you're doing something different than I think a lot of people thought about. So what's different about the approach you've been taking?
So what we've been taking is a multidisciplinary approach, so we're kind of involving all the different stakeholders in the issue at hand. So we're not only looking at industry, but also looking at the engineers that are going in and cleaning up these sites, and also the communities that are impacted. And so the National Institute of Environmental Health Sciences funds our program, and so they require what they call research translation, which is taking the science and translating it to different stakeholders and also community engagement. So that's why kind of we have this holistic approach where we're considering everybody in it, and it's just kind of trying to move forward all the work that we're doing.
And it was interesting to me to see that this program is based in the College of Pharmacology or Pharmacy, School of Pharmacy?
Yes.
Okay.
So our previous director is Dr. A.J. Gandolfi, and so he retired recently, so the program is still housed there at the College of Pharmacy.
Okay.
Our new director, Dr. Raina Mayer, is out of the Department of Soil, Water, and Environmental Science.
Oh, okay. So it truly is multidisciplinary. You have quite a range of expertise in there.
Correct. So we have the health sciences to the engineers to the people that do the remediation.
Is there any other program like this in the country that's taking this kind of approach?
So yeah, so there's various Superfund research programs around the nation. So it's a competitive grant that NIEHS has, and different universities compete in it.
Okay. All right. How long has the program been around?
For over 25 years here at the University of Arizona.
Okay. That's incredible. Well, one of the things you talked about, and I think that got my attention, was the mining modules. And there's a couple different modules and programs you have. So can you tell me what are the programs, these mining modules and related programs that are going on?
Yes, we have two mining module projects. The first one is the Promotoras, and that's reaching to the Hispanic community. And then the second program is the tribal educational modules, which are focusing on the tribal college students as well as tribal members that have been impacted by mining.
Okay, and you have a program going with the Tohono O'odham Community College. Can you elaborate a little bit that?
Yes. So the tribal educational modules that we have developed is for tribal colleges and tribes across the United States. So in the beginning of the program, we decided we wanted to reach out to local tribes, and the Tohono O'odham Nation is our neighbor here. And so we reached out to them and discussed the possibility of creating educational modules that will focus on mining and also impacts of mining. And so we went to the Tohono O'odham Nation and the Tohono O'odham Community College, and we had a discussion with them, talked about what their needs and desires were in terms of education and understanding mining and mining impacts. And so we worked with them collaboratively to develop these mining education modules.
Okay, and it's not just the impacts, but as I look at some of the courses, it strikes me as you're perhaps helping train some of the students there for potential careers in the mining industry.
Yes. So the educational modules are independently packaged units of topics related to copper mining, which is very relevant to the Tohono O'odham Nation, reclamation, environmental impacts, and the socio-cultural impacts of mining. So we came in wanting to do mining and mining impacts of to the total of the nation, but they also requested specific topics, particularly socio-cultural impacts. That's very important to the tribe. So we work together to define the topics that would be in these educational modules. And so they're targeted to the tribal college student. And so a tribal college instructor can take any portion of the tribal educational module and incorporate it to an existing course. And so they're independent that way, but yet the resources are there for the instructor to have the instructional guide to provide the background, as well as a parallel PowerPoint, which the instructor can take out what she or he needs, and then a hands-on activity and any supplementary supporting material. So it's very mobile and can be fit into a variety of natural resource courses or any sort of STEM courses. And ideally, it can also be used in other settings, not just tribal college. It can be in community setting or with Denise's promotoras. It's used in a community health representative situation. But another goal that we have in terms of the tribal college student is creating a pipeline and bringing the tribal college students into the University of Arizona, where they may pursue a major in engineering, mining, and environmental sciences, and then one day go back to their tribe and build a capacity of their tribe to address issues directly related to mining and environmental impacts of mining.
Okay, so it sounds like you're developing this as a prototype here, and then is this something you expect to then make available to other tribal colleges across the country?
Yes. Our next partner we'll be working with this year is the Net College, and we'll be developing a module related to uranium mining and mining impacts of uranium mining.
And is that based up in Window Rock?
Yes, the capital is in Window Rock, but the nation actually spans out to New Mexico and Utah.
Oh, right. I realize that, but is the college in Window Rock?
The college is in Window Rock.
Okay.
There's also a STEM-focused campus in Shiprock, New Mexico. But they also do have satellites campus across the Navajo Nation. So those are the two tribal colleges we're working with now. We also reached out to AHEC, which is American Indian Higher Education Consortium, and that's consisting of tribal colleges across the United States. But our idea is to eventually have these modules available for tribal colleges across the United States.
Fantastic. Now, you mentioned the Promotora program, and I think you're running that one. Tell me what that is.
So basically, promotoras are community health workers, and it's a model that has been transported from Latin America. And so we began working with them in 2007, and a big thing that we noticed is that there was a lack of environmental science training for them. So we kind of did some here locally with a group, and we started kind of talking about it at different forums, especially US-Mexico forums. And a lot of promotora groups became interested in the trainings that we're doing, and they suggested to us to develop modules for them based on train the trainer model. And so we did this for them, and so we've developed 3 topics, which is pesticide, arsenic, risk assessment, which we're finalizing right now, and environmental toxicology. So we're working with different promotora groups in Mexico, the US-Mexico border, and southern Arizona to train them on the topics and how to use the modules, so then they can go and train other promotoras and so on and so forth. So there's an expansion of environmental science training within the promotora community.
That's incredible. Okay. Well, we're running out of time here. Is there anything else either one of you want to mention that I haven't talked about. There's so much that you're doing. I'm sure there's a lot of other things that are really exciting. We may have to have you come back and talk about some of the other aspects, but is there anything you'd like to wrap up with?
Sure. I think one unique aspect of this program is that although we're reaching out to specific community members and impacted communities, but I think that the content of these modules are very useful and relevant for other communities, and so we do also want to have the educational modules available for community colleges, and it's just a way to provide more educational opportunities at distance education.
Okay, so all of these materials are available on your website, or going to be available on your website?
Yes, they will eventually be available. We're working on the website right now and polishing up some of the final details of our first educational module.
Okay, fantastic. Well, best of luck in both of you. That's exciting programs, and thank you for joining us today, and we're going to ask you back to hear more about the program in the future.
Thank you.
Okay, thank you.
Thanks.
Hi, I'm Mike Conway with the Arizona Geological Survey, and this is part of our June issue of the Arizona Mining Review, and we're on the road today with Brigette Martini at Bronco Creek Exploration in Tucson, Arizona. And Brigette Martini is working for a group out of Australia called Corescan, and she and her company have brought this device to Tucson to begin the process of scanning core. And she's going to tell us a little bit about what she's doing and what Corescan is doing and where this device is going to be headed shortly.
Mike, thank you.
Hey, thank you.
Welcome to the Corescan facility here. This is our mobile unit. These are manufactured and designed in Perth, Australia, and we have several of them in Australia and in Santiago, Chile, and now we're coming here to North America. And this is our first lab. We've come here into Tucson for a couple of weeks, and then we're going to be heading down to Mexico. But we have this great opportunity to be here and scan rock for the university and for the survey.
Very good.
And for some other paying clients. So the lab here is basically a mobile unit for automated mineralogical mapping. And the basic principles of it is it's using IR spectroscopy as well as photography and laser profiling. And so the system is fully contained within this unit that we're in right now. And this unit is highly mobile, so it can be brought to your mine or to your repository, or you can bring your core to us and have it scanned.
Very good. And so you just landed here in Tucson. How long are you going to be here?
So we're going to be here probably till next Friday.
Okay.
As expected, we kind of planned here to be a week, and then people brought more and more core, so we're going to stay another week before we head down to Mexico.
Very good. Can you run us through a little bit about the facilities in here?
Yes. So, core preparation, so people bring us their core, and the core preparation is actually done outside, out of the lab, and we try to keep this as clean as possible inside. Once the core is ready to be scanned, we bring it in here through a slot in the door behind us here, and then it comes through onto the conveyor belts, and this is the system itself. So here's Corescan. All of the measurements that are going on within this unit. There's a laser profile or a camera and a spectrometer. And I'll show you actually working here in a second. The core boxes go here. We can scan obviously something as long, quite a bit longer than this, up to about 1.5 meter trays. But here's a pretty standard core box here. This is from the university. We program the system so that it knows the shape of the core box, so we don't have to keep redoing that every single time. But we can scan pretty much any shape of anything. So it's not just core, of course. We can do met samples, we can do cuttings, hand samples, big slabs. Some people have brought us big slabs of rock. Basically, if it stands still, we'll scan it. So it goes here onto the bed, and all of it is operated here by a single operator. So we usually have two guys that are operating it. One whom is outside prepping the core, and the other person who's actually running Corescan. So it's not rocket science, it's pretty simple to run. So we'll get it started scanning here. And the instrument is going to get ready to scan. The first thing that we do is we calibrate the system, because this is an imaging system. We have to calibrate the actual reflectances coming out of the instrument. So you can see the calibration tray comes out here. And First we do a gray target, so a slightly darker target, and then we do a bright target, sort of a 100% reflectance target, and then we actually measure a doped rare earth sample in order to align our wavelength bands. This instrument measures from 450 to 2500 nanometers wavelength range, but we will be adding a thermal module later this year that will do 8 to 12 microns as well. The resolution of the instrument is 0.05 millimeter for the photography and ½ millimeter for the hyperspectral. So now we'll actually start the scanning.
Excellent.
And you can see here the red line is the laser, so that's actually getting the topography. These are flat slab samples, so there's not much topography. And then we're getting the camera is coming in and taking the photos, and then this white line that you see here, that's actually 2 quartz halogen lamps shining in, and that's actually where the hyperspectral measurement is taking place.
Very good. And your clients for these types of analysis, who are you servicing?
So currently, Corescan probably does 90% mining. We have 10% other, and that includes geothermal, oil and gas, and university researchers.
And you expect that 10% other to grow over time?
Yes. We do see oil and gas continuing to grow, particularly in the shale gas, where it's actually much more like an ore deposit.
Right, very good.
We image the types of minerals. People often ask what we're actually mapping. We're mapping all of the major types of minerals. So we're doing clays, sulfates, micas, carbonates, iron oxides. So that's the types of minerals that we're mapping.
And one of the products that you come up with is a mineral map that you hand off to the clients.
Yes. So the main products that the client is getting are a fully classified map of their core. So some people out there might be familiar with handheld instruments that take a single point, maybe down the middle of a core. And whereas that would maybe be 20 measurements for a meter of core, we're doing 100,000 spectral signatures across the face of the core. So puts very simply, it's an image rather than a single point measurement. So you're getting a full classification map, you get RGB photography, and then you get abundance images for each mineral that are found. So percentage of chloride, percentage of montmorillonite.
Okay. And now you're going to be headed to Mexico after this, and this is going to live down in Mexico.
Yes.
Are there any plans to bring anything into the United States and set up down there?
Yes, we're scheming away right now. There's another lab that's almost ready to go. When our designer who's here came over to calibrate, Nino, to Philly, when he heads back, he'll finish up that lab, and that lab will be ready to go. So we're basically figuring out where it's going to go here in North America, whether it's going to be the US or Canada. It's very mobile though, so I guess the answer is probably all of the above.
Okay.
That it will probably do a bit of a road show and go around various locations. But that is the plan, is for it to come here.
Well, good luck to you and Corescan, and thanks so much for doing the interview.
Yeah, thank you.
Mark Barton, a professor at the University of Arizona and associate director of the Institute of Mineral Resources, and we're very excited to have Corescan here and to be working with Brigette, given that she has a connection back to several of us here at the U of A many years ago. And one of the things that we're most interested in is just seeing how this new technology is going to help us tremendously in thinking about what goes on with our process of routine identification of minerals and textures in all kinds of different geologic environments. And because we're focused on ore deposits, as many of the other users would be, we're particularly interested in seeing if this is a good adjunct to what can be done with research projects as well as with the more routine industrial applications. So it's exciting to see what goes on with Corescan and to actually see it in person rather than to be introduced at distance with them. And one of the things that's fascinating, and perhaps you'll see a little bit more about this along the way from some of the others, is that samples like this, which have been difficult to identify routinely as research geologists in the field, now we have the opportunity to get a great deal more rapid mineralogical information out of it than we had before. So although we don't have the continuous core the way a mining company might have it, we have lots of hand samples that we've characterized in other ways, and it'll be marvelous to see what we can do with it along the way. We're keen to share it with Corescan and hope that in the long run this becomes an important part of what the greater community here in Tucson is going to be able to do, whether it's at the university or things like the Arizona Geological Survey or with the many mining companies and exploration companies that are working in this area.
Thanks again for joining us on the Arizona Mining Review. Our producer-director is Mike Conway. Technical support from Ron Palmer. Our media intern from the University of Arizona is Jenna Favell. Logo and set design was Stephanie Marr. And our editor, cameraman, Jordan Maddy.